AP chemistry video. This is part 3. We're going to be talking about molecular shapes that have an octahedral geometry, and that means it has 6 total domains. So our first example is going to be octahedral in shape also. We have the central atom and 6 bonds. And the ideal angle here is going to be 90 degrees. So let me show you with the FET. Uh-oh, it's not liking me. So let me make this one. So 1, 2, 4, 5, 6. So if I turn on my geometry, it says it's octahedral, and I'm going to show my bond angles. You can see they are all 90 degrees. So this is an octahedral shape. So an example of this would be SF6. You'll end up with sulfur in the middle and the fluorines on the outside and no lone pairs on the sulfur. Another example of octahedral geometry, but with only 5 bonds and then 1 lone pair. And we call this square pyramidal. An example would be F5. So let me show you with the FET. So this one we could go and do, it's not going to let me do that. Okay. I'm going to pull down and grab, I think there's one in here. Let me look. No, it won't let me. Okay, we'll go back to the model. So it is going to have 1 less bond and 1 lone pair. So you can see why, I think if you look at it like this, you can see why it's called square pyramidal. All right. So all of these have 6 total domains. Next one, now we're going to have 4 bonds and 2 lone pairs. And this is called square planar. An example would be xenon F4. So let me show you this. So we will remove another bond and we're going to add another lone pair. And you can see the way the lone pairs arrange themselves in space and how this ends up being planar now. So this is called, like I said, square planar, and you can see that it has those 90-degree angles. So just a couple more. It's also possible to have A with 3 bonds and 3 lone pairs of electrons. This is called T-shaped. I don't have an example right now. Sorry about that. And then the last one is a XX, so 2 bonds and 4 lone pairs. And this is linear. Again, I don't have an example for those last 2. But let me show you on the FET. It's pretty cool. So the first one I'm going to do is the T shape, which is going to have 3 bonds. And then it's going to have 3 lone pair. So you can see, like if you put it like that, you can see why it's called a T shape. And then the linear, we're going to take off another bond and put in another lone pair. And you can see how all of those lone pairs repelling around the central atom, and then it ends up being all in line, which is linear.